At first glance, this looks like a normal calculator. However, don't judge a book by its cover. This isn't any ordinary calculator which you can buy. It's a stealthy cheating device which packs a display and integrated Wi-Fi hotspot and is also linked to Google's Firebase database. To turn on the display, trigger the read switch at the bottom using a magnet. Then you can navigate to download and fetch all the data that you need, or why not seek help from a friend over a text message. In this video, we shall see how to make modification to your own calculator and also check out the other features of this modification. It's one of the complicated projects that I have worked on for YouTube so far. So make sure you stay till the end of the video and not miss a single thing. So without any further delay, let's get started. Our target place to work on will be the space which is occupied by the solar panel. So let's start by carefully dismantling the calculator and desolder the solar panel. I'll save this solar panel for future projects. Now, on the other hand, cut the extra plastic on the back of the case and sand it, which will provide us more room for OLED and the ESP. You can see that the space is perfect for 0.91-inch OLED display and as well as for an ESP12E. But before directly jumping in and messing up with 12E and the OLED circuit inside the calculator, let us start building a prototype for Node MCU which is also based on ESP12E. This circuit is very simple and minimal. Just connect the I2C bus of the OLED to D1 and D2 of the Node MCU. In order to navigate, we will be using the Hall effect sensor instead of physical buttons to control the navigation on the screen. These 314A Hall effect sensor have 3 pins: ground, VCC and digital output. The sensor pin 3 goes low when placed near a magnet, depending on the polarity of the magnet. To reduce the number of components inside the calculator, I'll be just using 2 of these sensors for all over navigation. Solder this sensor to pin D7 and D6 of the Node MCU, and that completes our circuit. This circuit was very simple, but on the contrary, the programming got way harder than I thought. First, let's start with downloading the necessary library for programming in Arduino IDE. I strongly recommend you to go back and watch my video on how to program an ESP for better understanding on how it works. Download the ESP core for Arduino through Preference and download the ESP8266 board. Then open the library manager, download the Firebase ESP8266 client. This library will help us in integrating the Node MCU to Firebase. Download the Arduino JSON. This will help us in parsing JSON data that we can use in Node MCU. Finally, download the One button. This library will help us a lot in reducing the number of inputs that we need by giving the functionality of single tap, double tap and long press. The flow of the program is a bit complicated to explain on a single video, so I have a flowchart on my GitHub to show the flow of the program. But for now, we'll just see how to set this up. First, go to Firebase and set up the server. Go to console, add project and name your project. Then next and finally finish. Once this setup is done, go to settings and copy the web API. Then go to the database, create a real-time database with the test mode. For the chat functionality, just add the users you want to chat with in the real-time database. Now copy the HTTPS URL link on the database, go to the code, replace the Firebase host with database link and Firebase auth with web API key. Then change the Wi-Fi name and password from where you would want your calculator to connect and fetch data from. Now just compile and upload the code to the Node MCU. You can see the prototype is working completely fine. Once you are happy with the way it works, start preparing the calculator with an OLED and an ESP. I placed the OLED and glued them with an epoxy on one side of the calculator and glued two hall sensor and reed switch on the other side of the cover with the tracks for the wires which goes to the battery and the regulator. Now you can replace the Node MCU with 12E. When you Google for the pinout of the Node MCU, you can see they are relatively similar to the GPIO of ESP12E. So just connect them accordingly and follow the circuit diagram. The programming is similar to the ESP826601 which we saw while making the IoT LED clock. Just solder the GPIO pin 0 to ground and connect the FDTI and program as similar to the Node MCU. Compile and upload the code. While waiting for the code to compile, if you haven't subscribed to the channel, hit the subscribe button right now so you never miss an update. Once the code is uploaded, remove the wires and place a plastic sheet in between the ESP and the OLED to avoid any short circuit. And follow the schematic for soldering. However, I recommend you to use a higher gauge wire because with the wires, whatever I am using is very clumsy and too thick. Finally, I connected the ESP to power through a 3.3 volt regulator and to a reed switch. This reed switch is closed when it comes in contact with magnetic field and opens when the magnetic field is removed. The only trouble I am facing with this final circuit is charging. To keep it stealthier, I had to use a wireless charger and unfortunately I couldn't get hands on one of them. So I have taken two small single strand wires out of the case which I can use later to charge them with TP4056. Finally, once the connection is complete, just like before, place a plastic layer between the battery and PCB to avoid any short circuit and close the case. You can see the damages are minimal. If you could put more time and effort, I'm sure you can pull this off flawlessly. Before seeing how it works, I have a small surprise for you guys. The code and the circuit diagram will be in the description, but the code has 4 intentional errors I have added. Just so people who don't understand can't get hands on it and use it in a dumb way. But who knows a bit of electronics and basic programming, this will be a piece of cake. These errors are very easy to fix and you can fix them in no time. Now I'll set this up for the first time and we'll see how it works. Start with setting up the data which you want to show in the calculator. Then make the text file of the data and upload it to the Firebase storage. Now set up the calculator to fetch from this URL. Place a magnet on the Hall effect sensor which is connected to GPIO pin 12 and turn on the reed switch. This should turn on the hotspot in the calculator which you can connect to and store the URL from where you want the device to fetch the data from. Once this final setup is done, remove the magnet near the Hall effect sensor and restart the calculator. Here you can navigate the menu with a single tap and go inside the menu with a double tap. When you jump inside the downloads option, you can see the data is being fetched from Firebase storage and is being shown on the display. Now to scroll this up and down, you can tap and hold on either of the Hall effect sensor. To go back to the main menu, just double tap. In Ask Help menu, you can chat with your other friends in case if you have a multiple calculator just like this. If you guys are willing to donate your calculator, I can make another copy of this. Just DM me on my Instagram. To send a message, just tap and hold to go through a series of pretext messages. When you stop, the message will be sent. You can see the send messages on top corner of the screen. Now you can also receive messages. Since I don't have another calc to show, I will show how it works with Firebase in my browser. Just type the text you want to send the user and press enter. You can see now both the display and the database are updated simultaneously. To keep this device more stealthier, and if you are not comfortable using the magnet, you can either embed a magnet in your finger just like this guy, or a magnetic ring from Amazon. But there is one more trick under my sleeve. Just place a magnet at the tail of the pen and this would work perfectly. And now you are almost a perfect spy and hardly anybody can catch you.